Welcome to using AWS Single Sign-On with Okta, Active Directory, and AWS SSO Identities. I'm Ron Cully, Principal Product Manager for AWS Identity.
And I'm Yuri Dukovny, Solutions Architect for AWS. But Ron, wasn't the title working with different identity sources in AWS Single Sign-On?
That's right, but for those of you who saw my LinkedIn post, this is my surprise. So Yuri, you tell them.
Within the last hour, AWS and Okta announced that customers can use AWS SSO and Okta Universal Directory together to manage access to AWS. Later in the talk, I am going to show people how to configure these to work together.
That's fantastic. We've had a lot of customers waiting for that to come. Let's get started. Yuri, back in February, you did an AWS online tech talk on how to use Azure Active Directory with AWS SSO.
Yes, we showed people how to connect Azure AD to AWS SSO and use permission sets to simplify access assigned to roles across all accounts in your AWS organizations. Using Azure AD as an example of an identity source, we walked through how to configure permission sets and assign access to users and groups in multiple accounts.
For today, I thought we might dive deeper into another aspect of SSO and talk about how it works with different identity sources and the differences based on your configuration.
What you mean is you want to look at the differences in how AWS SSO works when you use Okta versus Active Directory versus SSO identities, right?
Exactly.
Today, we will not spend much time going into permission sets. Instead, we'll focus on how users and groups get into AWS SSO, how AWS SSO treats the source of users and groups from the standpoint of source of truth. To get started, let's first summarize what AWS SSO does and take a look at the logical representation of the AWS SSO architecture. The purpose of AWS SSO is to enable you to manage users and groups where you want and connect them to AWS one time. Assign your users and groups access to AWS accounts and AWS SSO integrated applications centrally, and provide a user portal where people sign in once to see and access all their assigned AWS accounts and roles and applications.
Let's look at the logical architecture of the system. First, AWS SSO needs to know who the users and groups are before it can assign access. The Identity Store is where AWS SSO keeps a copy of the required user and group information.
Next, AWS SSO has an authentication service that directs user sign-in to the identity system that manages user credentials. This part of AWS SSO is unique because AWS believes in letting you choose where you manage your identities when signing into the cloud. We give you three key options. If you want, you can create your users and groups inside AWS SSO and manage passwords and multi-factor authentication. Alternatively, you can connect it to an external identity source where you manage users now. Supported external identity sources include your existing Active Directory domain service and SAML 2.0 federated identity providers called IDPs. For example, Okta Universal Directory is a SAML 2.0 IDP.
Next, SSO has an authorization system where you create entitlements that determine which users and groups can access which accounts and applications.
AWS SSO also has an interface that enables AWS created applications to use AWS SSO as its authentication service and a user directory. So instead of having to federate to each AWS application separately, you can connect your users and groups once, and they are available to use with AWS SSO integrated applications too.
The last key part of the logical architecture is the user portal. This is the URL where your users go to access the AWS accounts, roles, and applications to which the SSO administrator has given them access. Let's talk about where you manage users and how authentication works. Ron, which identity sources should customers choose and why?
Many customers are new startups that don't have identity infrastructure in place. AWS SSO makes it simple for them to create and manage users and groups without setting up any other infrastructure. Currently, User management is through AWS SSO console only, making this appropriate when the scale of users is small. Many other customers are coming from data centers where they use Active Directory to manage users. They often want to move existing Active Directory dependent applications into the cloud and run them on EC2 to decrease capital expenses. These customers extend their AD into AWS so the applications continue working with their AD users and groups. Frequently, these customers follow the Microsoft Enhanced Security Administration model, also called the Red Forest architecture. In this case, they use AWS Directory Service for Microsoft Active Directory as a resource force for running the application. This also enables them to use other AWS managed services like RDS for SQL Server or Workspace's virtual desktops. Other customers use AD Connector to join EC2 and Workspace's instances to their AD domain directly. Once customers extend their Active Directory to AWS with either model, SSO can use those connections to authenticate AD identities without the complexity of setting up separate federation infrastructure, such as AD Federation Service. Other customers may already have federation infrastructure like Okta Universal Directory, and they use it to access SaaS applications like Salesforce, Office 365, or GitHub. Although they might federate to AWS accounts individually, many want a simpler way to federate once to use all their AWS accounts and AWS applications. These customers can connect their IDP to AWS SSO one time to access their roles in AWS accounts and AWS SSO integrated applications. The bottom line is that AWS lets you pick which model is best based on where you are beginning your journey.
So how does the choice of an identity source affect the sign-in experience?
If you manage users inside of AWS SSO, or you connect it to your Active Directory, then your users see an AWS sign-in experience. If you use a federated identity provider like Okta, then your users see the IDP sign-in experience.
So how does this affect multi-factor authentication use?
Multi-factor authentication is part of the sign-in experience. So if you use AWS SSO or Active Directory as an identity source, then AWS sign-in is where MFA happens. When using Active Directory, you have the option to configure MFA in AWS SSO, or you can set up Radius MFA in AWS Directory Service. If you're using a SAML IDP as the identity source, then MFA happens at the IDP.
As you may know, in Federation, the identity source is called the identity provider, IDP, and the application or service that authenticates to the IDP is called the service provider, or SP. When signing in, a user can initiate authentication by going to the IDP first and then navigate to SP. That's called IDP-initiated authentication. In this case, the user sees the sign-in screen of the IDP and signs in. Typically, the IDP sends the user to the IDP's user portal. From there, the AWS user accesses the AWS SSO user portal. Then the user navigates to the AWS accounts, roles, and AWS SSO integrated applications. Alternatively, the user might go to the SP first. In this case, AWS SSO. This model is called SP-initiated authentication. If the user has not yet authenticated to the IDP, AWS SSO redirects the user to the IDP where they sign in. The IDP then redirects the user back to the AWS SSO, which presents the AWS SSO user portal. At that point, the user can navigate to the accounts, roles, and AWS SSO integrated apps.
So help me understand another point. AWS SSO integrated applications like SageMaker Studio Notebooks has its own endpoint that a user can navigate to directly from their browser. How does this sign-in work for that use case?
That's right. As we just saw, AWS SSO looks like an application or the service provider to an IDP like Okta. But AWS SSO looks like an IDP to the applications. In this case, the user navigates the browser to the application. Detecting that user hasn't signed in, the application redirects the user to AWS SSO. Detecting that user hasn't signed in there, AWS SSO then redirects the user a second time to the IDP. After authenticating, the IDP sends the user back to AWS SSO, which in turn sends the user back to the application.
Thanks, Yuri. Now that we understand how AWS SSO authenticates users, let's look at how AWS SSO works with identities to assign access.
An AWS SSO permission set is a definition for an AWS role. AWS SSO administrators assign users access to permission sets in selected accounts. This process creates a role in the selected accounts and assigns the selected users to the role in AWS SSO. The permission and account must exist, and AWS SSO has to know who the users and groups are before you can assign a permission set. Let's see how AWS SSO learns about the identities from the identity source. When you create the users and groups in the AWS SSO Identity Store, it knows about all of the users and their credentials. When you use Active Directory, AWS SSO uses your AD connection to perform LDAP read operations for the users and groups and your domain controllers directly. If you use the SAML identity provider, the SAML protocol doesn't allow you to read anything from IDP. In this case, you have to provision the users into AWS SSO Identity Store so AWS SSO can read them. The best way to do this is to automate provisioning using the SCIM protocol. You can use this method with compatible IDP, including Okta Universal Directory and Azure AD. Another option is to manually create users and groups in AWS SSO, being careful to match the user sign-in name to the IDP sign-in name. This is useful if you have a SAML 2.0 IDP that doesn't have a compatible SCIM implementation. Now, let's take a look at AWS SSO integrated applications and how they use identities.
Okay, some AWS applications integrate with AWS SSO directly. This enables the application to use the same authentication experience and the same users and groups, but without having to federate and synchronize users separately. These applications often have fine-grained access control to resources inside the application. Although an administrator must give a user access to the application, as we just discussed, the application user may also be able to give access to something inside the application. For example, an IoT Siteways Monitor user can create a dashboard of IoT information and then share the dashboard with another user. These AWS SSO integrated applications do this by using the AWS SSO Authentication Service and its Identity Store. This enables the application user to search for users and groups.
A moment ago, I explained that when you assign access for Active Directory users, AWS SSO reads the users from AD directly. If application reads the users from the AWS SSO Identity Store, how do they find the AD users?
AD doesn't have a SCIM interface to synchronize users. So as a first step to make that possible, AWS SSO implements just-in-time provisioning for Active Directory. When a user signs in to AWS SSO for any purpose, AWS SSO authenticates them using Kerberos. It then uses an LDAP query to get the user metadata, excluding the credentials, and it saves the information in the SSO Identity Store. From then on, the application can search for and work with that user's metadata. Let's summarize all of this in a source of truth table for the different configurations.
Okay, for a given identity source configuration, this table shows where AWS SSO authenticates, where you control MFA, where users and groups come from when assigning access to permission sets and applications, and where users and groups metadata comes from for use by AWS SSO integrated applications. When you use AWS SSO as your identity source, AWS SSO performs authentications and manages MFA. AWS SSO is also the source of users and groups for permission sets and applications assignments, and for users' metadata used by AWS SSO integrated applications.
When you use Active Directory as an identity source, AWS SSO authenticates users using Active Directory, and you control MFA in AWS SSO or in AWS Directory Service. Active Directory is the source of users in the groups used in permission set and application assignments. AD is also the source of user metadata used by AWS SSO integrated applications, and it gets synchronized in only when users sign in.
If you use a SAML IDP but manually provision users and groups into AWS SSO, then AWS SSO uses the SAML IDP to authenticate, and you manage MFA at the IDP. The AWS SSO administrator adds users and groups to the SSO Identity Store, which is the source for permission sets and application assignments, and for user metadata used by AWS SSO integrated applications. Finally, if you use the SAML IDP with scheme synchronization, the IDP is the source of truth for authentication, MFA, user information for assignments, and user information for application use.
Let's show how this appears to the AWS SSO administrator through some demonstrations.
First, let's look at a simple case of using AWS SSO as your source of truth. I've signed into my AWS account and opened the AWS SSO console. In the settings page, I can see that my identity source is AWS SSO. When I go to the users page, you can see I already created some users. You can also see there is an Add User button. This tells you that the source of truth is AWS SSO. When I add a user, you'll notice that you must specify a username, a password, a first name, a last name, and a display name. The username and email may be the same if you wish. I also have a number of other attributes I can configure for the user. Most of these attributes are standard attributes from the schema specified in the System for Cross-Domain Identity Management. If you plan to use AWS SSO to sign into Office 365, there is also an immutable ID that you can configure. As I add my user, I have the option to add them to groups. Alternatively, I can navigate to the group page. I've already added some groups here as well. Here you see an Add User Group button. This means that AWS SSO is the source of truth for all group membership as well. That completes the tour of managing users and groups in the AWS SSO Identity Store. Let's take a look now at the Active Directory use case. Going back to the settings page, I'm going to change my identity source to Active Directory. This drop-down box lists the AWS Directory Service directories that I previously set up in my AWS Organizations master account, and I can use that as a source for AWS SSO. In this example, I'll use the AWS Managed Microsoft AD directory, mydomain.com. As I make this change, I receive an alert that this will remove all existing users, groups, and assignments. Now that I'm finished converting to using Active Directory, I'll navigate to the SSO Users page to see what is inside the AWS SSO Identity Store. You'll notice there are no users. That is because no users have yet signed in to AWS SSO. Active Directory users only appear in the Identity Store after they sign in at least one time. You'll also notice that there is no Add User button available. That's because Active Directory is the source of truth for user information. There is a Remove button that enables me to remove users that previously signed in but have since been deleted from Active Directory. Navigating to the Accounts page, I will select some accounts to assign access. In this case, I have a search option that lets me look for users in any domain available through my AWS Directory Service. In this case, I will search for users in my AWS Managed Microsoft AD domain. I select my user and select Next. I've not yet created any permission sets to assign. For brevity, I will create 2 permission sets using the pre-configured existing job function policies. Next, I will select the permission sets to assign them to Pat and select Finish. Using the permission sets, AWS SSO creates roles in the selected accounts and grants Pat access. I will now return to the settings page to get the user portal address to send to Pat. Pat goes to the portal address and signs in using Active Directory credentials. Pat now sees the 2 assigned roles in the 3 accounts and can access the AWS console. Now that Pat has signed in, as the administrator, I can go back to the SSO admin console, refresh the user tab, and you'll now notice that Pat appears in the SSO Identity Store. Pat is now available for use within AWS SSO integrated applications such as IoT Sitewise Monitor. Now let's look at how this works with the SAML IDP.
In the case of using an IDP, you have the choice of automating user and group provisioning or doing it manually through the AWS SSO console. First, in this demo, I'm going to show you how to connect Okta to AWS SSO with SAML 2.0 and SCIM. Looking at my AWS SSO deployment, I see that AWS SSO is my identity source. I'm going to switch my identity source over to Okta now. I choose external identity provider, and I will save the consumer URL and the issuer URL to provision them later in Okta. Next, I'm going to the Okta administrative portal and create a new application. I search for AWS Single Sign-On, click Add, and leave the default name for my application. Now, I'm going to configure SAML 2.0 integration with AWS SSO. In the Sign On tab, I click Edit, and I enter the consumer URL and the issuer URL that I saved before. I will also download and save the Okta IDP metadata. I will upload it to AWS SSO. To complete my SAML integration between Okta and AWS SSO, I am going back to AWS SSO console and will upload the Okta metadata file. I click Review, and AWS SSO prompts me with the number of warnings. It tells me that I must complete my external IDP federation configuration, that my existing AWS SSO MFA configurations will be removed and MFA will be handled by the identity provider. Also, if I have an existing users in AWS SSO, they will be retained, but they will be not able to sign in if they don't exist in my IDP. I confirm the change, and I have my SAML 2.0 federation with AWS SSO complete. Now, I am going to configure the SCIM users and groups provisioning from Okta to AWS SSO. I enable automatic provisioning in AWS SSO, which creates a SCIM endpoint that Okta will connect to. I save my SCIM endpoint URL and the access token. Now, I am going to the Okta AWS SSO application configuration and click Provisioning. I enable API integration with AWS SSO and paste the AWS SSO SCIM endpoint URL and the access token. I test these credentials, see that it's successful, and save. I choose all the options in Okta to AWS SSO users and groups provisioning. Create users, update users' attributes, and deactivate users. I also can change an attributes mappings here, but I leave everything as default for this demo. To make my AWS SSO application available to the users, I'll assign it to the AWS Cloud Access group that contains all users allowed to access AWS accounts and services. And to finalize my scheme integration, I have to choose the Okta groups that will be synchronized with AWS SSO. Later, I'll be using these groups to assign access to AWS accounts in AWS SSO. All my AWS groups starts with AWS, so I create a rule named AWS that will automatically include all of my AWS groups. Before going back to AWS SSO, let's quickly check the assignments and see that my AWS SSO application assigned to all my users allowed to access AWS. Now, going to the AWS SSO console, you can see my Okta users being pushed from Okta to the AWS SSO. Note that I no longer have an Add User button. That tells me that Okta is now the source of truth for my users and groups. Looking at the one of the users, you can see that it's updated by scheme with the user's attributes from my Okta Universal Directory. Looking in the group list, you can see that Okta groups synced to the AWS SSO. Now, if I add users to the groups or remove users from these groups, or update users' attributes in Okta Universal Directory, these changes will be propagated to the AWS SSO by scheme. Now, I can go and assign some access to my users' groups to AWS accounts. I choose my dev and test accounts, assign users, select AWS Developers Group, and use Power Access Permission Set. If I will also assign some of these groups to an AWS SSO integrated application, such as AWS SageMaker Studio Notebooks, the users that Okta just synchronized with AWS SSO would also have access to this application. Now that I've shown you how things work when you connect Okta Universal Directory to AWS SSO with SAML and scheme, let me share what happens if you use an IDP that doesn't have scheme integration. I am going to now disable scheme from my AWS SSO configuration. I go to the setting page, go to the provisioning link and disable scheme. Backing up to the setting page, you can now see that I have an external identity source that uses SAML 2.0, but the provisioning is manual. Going to my user page, I can see that Add User button came back. That means AWS SSO is now the source of truth for users and groups metadata. But because I have SAML 2.0 set up for authentication, my Okta IDP is source of truth for authentication. At this point, the AWS SSO administrator now controls which users and groups are in the configuration. If this had been a new installation, my user store would have been empty. I would add the users manually, making sure that the sign-in names match to what is in my IDP. For demonstration purposes, let's just pretend I manually entered these users and groups. At this point, as an end user, I can go to the AWS SSO user portal and sign in with my Okta user experience and perform work on the accounts and applications assigned to me. One thing to be aware of is that when you use your manual provisioning, the AWS SSO application controls group names and group membership. The group names do not have to match anything in the IDP. If you ever envision a time when your IDP has a compatible scheme implementation, you may want to keep your AWS SSO group names the same as they are in your IDP.
Let's recap what we just covered. We explained that you can create users inside of AWS SSO, connect them from Active Directory, or connect them from a SAML 2.0 IDP. When you use Active Directory or a SAML IDP, AWS SSO always authenticates at the identity source. AWS SSO is the source of truth for user metadata, groups, and group membership anytime that you have the ability to edit them in AWS SSO. Otherwise, the identity source is the source of truth, and AWS SSO simply holds a copy that is synced in from the identity source. Active Directory uses a just-in-time sync mechanism. AWS SSO integrated applications only see the users after they have signed in at least one time. When you use SCIM or you manually provision users and groups, the user and group information is available to AWS SSO integrated applications as soon as you sync them in. If you switch from AWS SSO users to an IDP, AWS SSO preserves the users, groups, and their assignments for usernames and group names that match the IDP. We also announced that Okta and AWS SSO now work together for SCIM synchronization and SAML authentication. And finally, we saw demos of using AWS SSO users, Active Directory, and Okta Universal Directory users. To learn more, visit aws.amazon.com/single sign-on and aws.amazon.com/directory service. For a more comprehensive picture on how AWS and Okta integrate, you can visit okta.com/partners/AWS. To get started, AWS customers can enable AWS SSO from the AWS Management Console. Okta customers can search for the updated AWS Single Sign-On integration from Okta Admin. Thank you for watching.